Moving on to exponential equations at the bottom of page 4, we're first going to refresh our memories over the exponential equations that we do know how to solve. So that process is summarized in the box. Before I read over that, remember how you can identify an exponential equation as an exponential equation. Okay, it's got to have an equal sign. And x, the variable that you're solving for, has to be located in the power or the exponent. Okay, so what we've learned so far is how to solve an exponential equation that can be written in the form a to the power u is equal to a to the power v, meaning both sides can be expressed with the same base. Okay, you have a power of a is equal to a power of a. Okay, so if necessary, you need to rewrite one or both sides of the equation as an exponential expression with the same base. Okay, so the ones we saw previously, sometimes they come with the same base. Other times you're not dealing with the same base on both sides of the equation. Okay, so our goal back then was to try to make all the exponential pieces have the same base. Okay, you have to use the laws of exponents to do that. Remember that. Okay, so then step 1 should have resulted in an equation of the form a to the u power is equal to a to the v power. Since the bases are the same, and bases in terms of exponential functions means the thing that you're raising to the power. So if you have the same bases, the only way a to the u can equal a to the v is if u is equal to v. So you need to set the exponents equal to each other. Okay, that gets rid of the exponential piece. So then in step 3, you're able to solve for the variable x. Okay, something that's worth mentioning for sure in step 4, it is not necessary to check your solutions in the original equation like it is for logarithmic equations. The reason is with logarithms, you can get in trouble by plugging in something that causes you to take the logarithm of a negative number or of 0. But with exponentials, the domain of an exponential is all real numbers. You can plug in anything you want to an exponential function. So if you do plug in something and you have to take the exponential of something negative or the exponential of something, or e to the 0 power, for example, you can do that. Okay, so it is not necessary to check your solutions with exponential equations. Okay, so here we go. We're going to move on to the next page on example 4. Okay, there are 2 examples of these types of exponential equations. This should be something you know how to solve already. Okay, so this should be a refresher. The directions say to solve each exponential equation, express irrational solutions in exact form, meaning no decimals, and then also, if necessary, give a decimal approximation rounded to 3 decimal places. Okay, in part A here, okay, the exponential equation is 5 raised to the negative x power is equal to 25. Okay, why is this an exponential equation? Well, you've got an equal sign. X, the variable, is in the exponent. Okay, so what you should always try, because guaranteed your exponential equations will get more difficult and then they'll all be mixed up. You always want to start by seeing if you can get the same base on both sides. Okay, so when you look at this, I have base 5 on the left, and then I have base 25 on the right, because the right is 25 to the first power. Okay, we need to try to have the same base. You always want to try to change the bigger number into the smaller number. Okay, so we're going to try to make both sides base 5. Since the left side is already base 5, we're going to leave it alone. We're not going to make any changes. On the other side, 25. Okay, 25, we need to rewrite it as a power of 5. Okay, well, 5 squared is 25. Okay, so the quantities in blue are the same. 25 is the same thing as 5 squared, or 5 times 5. Okay, now on both sides of the equal sign, we have a power of 5. The only way a power of 5 can equal a power of 5 is if the powers are the same. So we're going to equate the exponents. So negative x has to equal 2. Okay, we need to solve this for x. Since x is multiplied by -1, we're going to divide off the -1, okay? And that tells us that x has to equal -2, okay? And we're done. We don't have to worry about checking the solution unless you just want to see if you got, you want to make sure that your answer is correct, okay? All right, let's try a slightly more difficult one in part B. We've got 4 raised to the 5x power is equal to 32 raised to the x minus 1 power. Okay, again, you got an equation, got an equal sign. X, the variable, is located in the power. That makes this exponential. Okay, you want to try your first try, and again, it may not work, as you will see a little later. But your first thought is going to be to try to equate the bases. Okay, on the left side, I have base 4. On the right side, I have base 32. Okay, we need to make them the same base. Okay, so you always want to try to rewrite the bigger number in terms of the smaller number. Okay, so let's try powers of 4. Okay, we're trying to convert 32 into a power of 4. 4 to the first power is 4. 4 squared is 16. 4 cubed is 64. Okay, whoops, there's no 32. Okay, so we've seen a situation like this. This just means you're going to have to change both of the bases into something else. Okay, both 4 and 32 are powers of 2. Okay, so that's what we're going to use as our base. Okay, let's rewrite 4 first. Okay, 4 is 2 squared. Okay, so the quantities in yellow are identical. 4 is the same thing as 2 squared. 4 needs to be raised to the 5x power. Okay, so that's how you're going to change the left side. On the right side, we need to rewrite 32 as a power of 2. Okay, so 2 to the first power is 2. 2 squared is 2 times 2, that's 4. 2 cubed is 2 times 2 times 2, that's 8. 2 to the fourth is 2 times 2 times 2 times 2, that's 16. 2 to the fifth is 2 times 2 times 2 times 2 times 2, that's 32. Okay, so 32 is 2 to the fifth. The quantities in blue are identical, both 32. Okay, on the right, we need to take 32 and raise it to the x minus 1 power. Okay, so that's how this should look. Okay. All right, so we've got the same base on both sides. Okay, before we can equate the exponents, we have to simplify the powers. Okay, so on the left side, you have 2 squared raised to the 5x power. Okay, this is when the laws of exponents come in. Okay, so remember, you have a couple of laws of exponents that you need to know. Okay, you've got this situation versus this situation. Okay, so remember the difference. If you're over here, look at this first property. If you have a to the m power and then that quantity raised to the n power, this is a power raised to a power. This is when you multiply because the exponents are side by side. That's when you multiply. Okay. In the second property, you've got a power of a times a different power of a. The exponents are not side by side because the second a is in the middle. Okay, so this is when you want to add the exponents. Okay, so based on these laws, okay, what we have on both sides of the equal sign matches situation 1. We've got a power raised to a power, so we're going to multiply the exponents. So the left side is going to become 2 raised to the 2 times 5x power, which is 2 to the 10x. The right side is going to become 2 to the, we're going to have to multiply the exponents here. You're going to have to take the 5 and multiply it by the package deal x minus 1. Okay, so you're going to have to distribute the 5. Okay, so it's going to be 2 raised to the 5x minus 5 power. Okay, you have to distribute the 5 there, or it's not going to come out right. Okay, now we have a power of 2 equal to a power of 2. The only way that can happen is if the powers are equal to each other. So we're going to set 10x equal to 5x minus 5. Okay, it's linear. Okay, the highest power of x is 1. No longer exponential, so that's good. Okay, we need to get x by itself on one side. So I'm going to put all the x pieces on the same side. So I'm going to move this 5x over. That tells me 5x is equal to -5. divide both sides by 5. X has to be -1 here, okay? We do not need to check ourselves unless you want to for accuracy, okay? This is key, okay? When you recognize an exponential equation, okay, the first thing you're always going to want to try is to try to make the bases the same on both sides, okay? We're about to turn our attention to exponential equations that cannot be solved this way. So meaning, as hard as you try, you absolutely cannot make the bases the same on both sides. So we're going to talk now about what do you do in that situation?